excited about our next speaker. He's coming today from Minnesota. Although he is based in Phoenix, Arizona, he is at work today, broadcasting directly from Minnesota. And I'm talking about Brent Weichers. Brent has 35 years of lean transformation experience with Toyota and Danaher as the biggest portion of his professional background. He has trained agencies of the federal government and major corporations through their lean journey. He's currently the Senior Director of Continuous Improvement for North America for ICU Medical. Brent, it's a real privilege to have you with us today. Thank you for sharing your expertise with our global audience.
Oh, you're very welcome. I'm very excited. Okay, so a little bit about the automating standard work and the analyses involved. Standard work has always been one of those things that is very document heavy. Anybody that's going out and doing time studies and line balancing and trying to do some sort of capacity planning it's always been a very document heavy. I have to write time studies, I have to rebalance lines. I'm constantly looking at waste, walk waste, look waste, and all of this stuff has to be documented by hand. There's never, you eventually document it by hand, you put it into Excel or you put it into a capacity planning ERP system, but all of it is still very analysis heavy. Somebody has to sit down and formulate what work is going where and who is doing what work. If I go out on a shop floor and I do a time study and I decide, well, if I take work away from operator 1 and give it to 3, take stuff away from 3 and give it to 2, it might rebalance the line a little better. But now I'm interrupting production, which most in management will not be happy with. So what this system allows us to do is to do all of that electronically, is to give us a playground to do all of this type of analysis. And then once we have something that we know is going to work, we can go and implement it. So what we'll be looking at is, what are the elements of standard work? What's the documentation around standard work? The data sheet, which is the main part of this automated piece that we'll be looking at, how to do the time observation form, what the standard work combination sheet is and how that has been automated, the standard worksheet, which is also known as the spaghetti diagram or the footprint. I have some automation in that as well. The operator loading chart, which is a Pareto of the operator's load, which is fully automated now. A simple action plan is attached to this, but I also have automated printing, and we've also automated the capacity planning piece of standard work. So what standard work is just basically everyone in the band is playing the same song at the same time. And that's the whole idea of standard work, is to make sure everybody is balanced and everybody is working towards the same goal, which is TAC or TAC time, for the customer. So some of the prerequisites for standard work: operators have to be observable, repeatable, and it has to be based on human motion. And the process must be able to be standardized. So a shop floor supervisor or a cell leader, they have to be the ones responsible for the standard work. It can't be somebody, upper level manager somewhere responsible. It has to be boots on the ground responsibility. So the elements that we will be looking at in standard work is TAC and TAC time, which is the rhythm of the customer. Operator cycle time, how long does it take an operator to do the work? And then WIP, standardized WIP or work in process. So it all starts in this process. We start with the data sheet. The data sheet, we start out with adding what is the work area called. In this case, we're using the work cell, the magic valve. We're going to put the group name in, and we're going to add TAC or TAC time. So in this instance, we're looking at, I have 420 minutes available time for work. I need to build 80 units per shift. So the system gives me my takt time. It tells me how often I need to build one. So what I start doing next is I start adding the work steps. So I manually enter step 1, step 2. I only have to do this once in one place. I enter my work steps. So I enter step 1, step 2. So the key things to remember now, I'm going to start doing my time observation next. So the key things to remember is I need to take at least 10 observations if possible. Sometimes that's real difficult with long cycle times, but try to get 10 observations if possible. Oftentimes when they're very long cycle times is I'll use a GoPro, a video camera, and just set it up and film the operators over time. I'll ask the operator to work at a comfortable pace, and I use one sheet per operator. And that way I kind of like to mix the operators and have one operator do the first 5 steps, maybe have another operator do the first 5 steps, just to get a good idea of what the median time should be. And then, of course, make sure the operators always follow the same sequence of each time. And then once I have that, the process steps are automatically loaded from the data sheet. So when I go to produce my time observation form, as you see here, all of those steps for the component tasks are automatically loaded. So once I do my time study and I enter my times, as you see here, all of my times are entered in the white areas. So for step 1, I entered my 146, my 155. I enter all of those times for every sequence that I timed for step 1. And then it gives me a median time and then an adjusted time. Now what you're seeing there is the adjusted time is the same as the median time because I have one operator doing it. In some instances, I have 2 operators doing the same job. So if I had 2 operators doing step 1, I would put 2 in and it would adjust the time accordingly for me. So you always write the time in the top half of the box. The bottom half of the box auto sums automatically to give you the total cycle time. And then the date, the magic valve, the name of the process that you're observing, the units per shift, the takt time, all of that up above automatically is loaded for you. So once I have my time observation done and all of my cycles done, the interesting part is, again, that median time is so important. And then my adjustment factors, making any adjustments that you have to. So the 3 main elements on the data sheet that is automated is takt time is calculated. The operator cycle times, this is where you get to be creative. So in this instance, I have operator 2 doing step 3, but I can reassign that labor to somebody else. So if I'm out of balance and I decide, oh, I want to take step 2 away from that operator and give it to another operator to help reload the line, I can just use the drop-down menu, change the operator, and their sum of cycle time will change up above. So I made the change, and now you can see operator 1 is overloaded because they're red. They are over the takt time. Their cycle time is higher than takt time. So it's red, it's letting me know, and it's telling me I need to make a change. So I can go along here and just continue to move the labor around and give it to different operators. As you can see in this animation, I can change it from 1 to 2, and you can see how I can just keep moving labor around. until I get some sort of balance or get something that I think will work within the with that load. And as it changes and I rebalance the line, you'll notice that the current estimated number of operators here changes. So the more efficient I am on the line and the better balance I have, the number of operators I require drops, which is again showing my efficiency. So again, if an operator's time goes beyond TAC, then it turns red and lets me know that I need to go and manipulate the labor and move it around. So again, here I've got operator 1 is assigned step 1, 2, and 3. And there's the total, 269 seconds. So I'm right at the TAC limit. Operator 2 is doing 4, 5, and 6, 7. They're doing 4 steps. Their total is 268. So I know I'm right at the limit. So there's what it would look like. And as I add operator 5 and I add operator 6, it will just continue to put their cycle time and compare it to TAC time. But what this is telling me right now is I have 4 operators working this line. And down here it's telling me if I was in perfect balance, I would need 3.6, which again, of course I need 4 operators. There's no way to hire a 0.6 of an operator, unfortunately. But what this tells me is I could probably run that line maybe an hour less than the full shift and get what I need and use those people elsewhere, or take one person away at the last hour and use them elsewhere. You know, there's a ways to try to make that as efficient as possible. But this analysis will basically tell me, you know, in a perfect world, I still have a little bit of waste that I could try to eliminate. So the next piece is the combo sheet. And this was usually the piece that was the most labor intensive for people who are doing standard work. So a standard work combo sheet is the individual operator. And what does each person do and what are their steps and how long does that time take? So the sheet is the primary communication for standard work to the operator. So there's one sheet per each operator, usually posted in front of the operator, or it's posted at a KPI board at the end of the cell. It takes quite a bit of updating because as tech changes or demand changes, these need to be changed all the time. So again, it was very labor intensive. So now it's automated. So everything that you see on the top half of the page is automated. The part number, the name, the date, who it was prepared by, all of that is completely automated. So the only piece that you're actually entering yourself is the step number. So if I say operator 1 is doing step 1, 2, and 3, I enter step 1, 2, 3, and everything else self-loads. The only thing I would do is move the TAC line. So in this example, I've got an operator doing step 1 through 10. I put 1 through 10 in, everything self-loads. Now at times, the TAC time is going to be higher than 1,000 seconds in some long operations. So in the yellow square, you can change the scale of time across the sheet. So I can put a 150 or a 200, and it will change the scale across the board. So here I am, I have a blank sheet. I'm entering the steps that I'm going to have the operator do. Everything self-loads, self-draws. I'm going to change the scale. I can move the TAC line to where it needs to be, and done. I've just completed operator 1 standard work combo sheet. And sometimes you have up to 10 operators, and doing this by hand, again, was very time consuming. So now it's all automated. The other piece that is automated here is the operator load chart, which is all about balance. I always like to show this picture as the masters of operator balance is the guys in the pits. The guys are absolutely amazing at load balancing. So in this example, this was actually at a actual facility in Ohio. This was the load balance in the work cell. So there's this much waste in that work cell. We had all these people in there working away, but they were completely out of balance because we did not do operator load. So after a Kaizen event, this is what we ended up with. We didn't do anything in that cell other than rebalance the load. And that's what we ended up with operators. So in this case, this is what our magic valve looks like. Out of the standard work that we just developed, this automatically creates itself. So again, I'm looking at operator 3 and 4, have a little bit lighter load. I might try to take something away from operator 1 or 2 if possible and give it to 3 or 4. So this just kind of gives me an idea of where I sit currently with the load that I have on my operators. And there's also in standard work, there's something, everyone calls it the spaghetti diagram, but it's known as the standard worksheet. So it's kind of an aerial view of the cell. And what it's always been is literally that, just kind of an aerial view of where the workbenches are, where the people are. But the piece we added to this and automated was the walk time and the walk distance. So based on the number that are built every day, say in this instance, I think we had it set for 80 units a day. I go in and say, hey, I have to walk to QA for every unit I make. It takes me 72 seconds. I walk 88 steps. I walk to the cell. I walk to labels, on and on. So if I have to do that 80 times a day, once a unit, I put down my walk time, my walk distance, and down here on the bottom, it gives me a grand total of time and walk distance spent in that cell. So in this case, if I'm building 80 units a day and that's the walking that my operators are doing, they're spending 90 minutes a day walking, and they're walking 8.35 miles. It's amazing how many miles people walk. And oftentimes this piece was getting, I wouldn't say ignored, but it just wasn't getting looked at. It wasn't part of the analysis because it wasn't a work step that was being completed. So it was very important that this piece be included in the spaghetti map or the spaghetti diagram, is that analysis piece. So here's an example where I'm actually loading I'm loading walking back from the printer. They have one piece in their hand. It took them 67 seconds. They walked 85 steps. And you can see on the bottom how it changed to give me the total time and the total walk distance at the end. So an action plan is attached to this. There's no real automation in this piece. It's just having the action plan of the things that you're working on currently as part of the file. So you don't have to have that as a separate file somewhere. And then there's the capacity planning piece. It's great to have, I understand the standard work in the cell for that one particular component, say a motor that goes in a pump. So sample 1 may be just that. I did standard work for how I build the motor that goes in the pump. And at 10 a day, I need 1 operator and I use them at 58% of the shift. At 17 a day, I need 2 people and I use them 58% of the shift. my most efficient way to build the pumps would be using 3 operators at 91% of the shift. So I might use those 3 operators for 2 days to build my week's worth and then use them somewhere else. So what the capacity planning sheet does is it reads all of the variety of all the standard work documents that are out there. I did one for 10, I did one for 17, I did one for 40. It reads all the information off of those documents and puts it all on here for me. So what it's reading is the TAC, the number of benches, the number of people required, the cycle times, the percentage of operator usage. So all of that data is being read, and it comes out into a grand total that actually lets me know at a factory level, at 10 a day, I only need 7 people in this example. At 17 a day, I need 11 people to run my factory. So I can predict future-wise and say, well, how many people will I need at 100 a day? Well, I can very easily calculate what that would be with the capacity and labor planner that I have, because it's reading all of those standard work documents that are out there. So I'm not, if my manager came to me and said, what does 150 a day look like? I can very quickly have the system read all of those documents and give me an estimate of how many people and how many shifts we will need to build at that level. So a lot of companies have this capacity planning piece built into ERP systems, which are sometimes very cumbersome. They're kind of tough to run. And some companies are, in this case, I worked for some companies that were small startups. They were medical startups, and they didn't have some of the more sophisticated capacity planning systems. So for a lot of people, these kind of things work very well, is to have this all automated. It's basically, it's running on Excel with Virtual Basic running in the background. So at times they need to be printed. Sometimes we print these things and we have them hanging at the cell level for a KPI. So on the data sheet, there's a list of all of the pages that are available, and all you need to do is click which page you want to print and hit the print icon, and those pages come out for you. So you're not going to each individual tab. So that's the gist of the automated system that I have. You can download it. I have it available on a OneDrive, Microsoft OneDrive, and a few other sample files and some things are up there, as well as this presentation. So you can scan that QR code and you can do a download if you'd like. And then if you have any questions, the next slide I have actually has my contact information, but I know you can get that from this presentation as well. So with that, I'll open up to any questions you have.
Outstanding, Brent. Thank you for a deep dive into an application here, a digital automation that is not what, you know, most people will be thinking about in terms of using RPA, artificial intelligence, natural language processing. Here you are using good old Excel to automate a process to create real value, and that's really the key message here. So I'm going to ask you to stop showing your presentation screen so I can come back with my camera and ask you a few of the questions that came up during your presentation here. So first of all, a little bit of context about ICU Medical. I understand ICU Medical is a major medical equipment manufacturer, and of course that's the setting that you are showing this application at, and focus on IV therapies, right? You're like very much focused on IV therapies. But what is the context in terms of manufacturing facilities? You know, how many you're talking about? What kind of production levels do you have?
Well, even the facilities I am responsible for, there's multiples of them in the US, over a dozen. We have facilities in Mexico and Costa Rica that I all work with. And each one of those is producing up to, say, 1 million components a day. Wow. IV needles. Here in Oakdale, we're producing pumps So IV pumps, insulin pumps, even from the small one that clips to your belt to the larger ones that you see in hospitals. So that's our biggest manufacturing of those is here and in Costa Rica and in Poland. So we are very much a worldwide company. But anything to do with infusion type services for patients is some of the items that we manufacture.
And what is the typical, again, just for context, what is a typical manufacturing cycle time for like an IV therapy type of standard? Maybe if you'd call, if there is such a thing as a more standard product, if you will. And how automated is that process?
So one of our pumps here that we manufacture in Oakdale, the cycle time for that might be about 90 minutes. So we might have 6-7 operators. Each one is operating at about a 5.5 to 6 minute cycle time for their steps. But overall, so the drop-off rate is about every 5 minutes. But when you got 5 or 6 operators building the pump, and then we have multiple operators building some of the sub-assemblies that are feeding that line. And a lot of the automation we have in place is as each operator passes their unit to the next operator, we're doing an hour-by-hour automated tracking. So every work cell has a large screen up above their cell, and at any time I can walk by and see, you know, what happened in the last hour. This many passed, this many failed. What's my OEE? What's my roll throughput yield? I can see all of that hour by hour. So we're measuring the number of operators we used versus what, again, the standard work program says I should have 9 operators. So I only used 8 operators, but I did hit my number for that hour. I hit my 6-7 units, whatever my target was. And it tells me, it's like, oh, I was 105% efficient. So if I'm able to hit my target number with 1 less person, I want to know that as much as I want to know, hey, I was running with the right number of people, but I was only at 80% of my target. So anytime there's variance, it's letting us know, which is very important. But in order to have that measurement, that goal, we have to do this type of analysis. We have to understand every step of the process, every step of what each operator is doing, waste and value add, and be able to constantly see what's going on. So I can actually look at it and say, well, operator 6 today really struggled. So I don't have to guess at where the problem is. Like, it pretty much narrows it down for me because we're measuring it operator by operator.
And how did this become a focus for you? As you know, you look across the different facilities, the different ideas for improvement and innovation that you have in the system. How did you land on this one? And if you can talk a little bit about how do you even start prioritizing, you know, what you're going to work on when you have, you know, such a large system with lots of probably ideas on things that we can do different and better. What is the governance like for identifying, prioritizing what to work on?
Yeah, we have our continuous improvement group, which is myself and my counterparts in England and across Europe. So we meet constantly, and with our manager based out of Costa Rica, which is one of our largest sites, and we're constantly looking at OEE, OPE performance. So for the manual side, we look at OPE. For the machine side, the automated side, we're looking at OEE measures, and we're constantly reviewing those. And as soon as we see that or backlog, we start seeing backlog build up, where nice problem to have. I've got too many orders to get out the door. That's where we start focusing. It's always the customer. So we're always focused on what can we do to get that backlog out the door, or if our equipment or our systems are not performing as to standard, something changed. And that's when I get on an airplane.
Very good. And several of the folks who are in this call are not in manufacturing processes, right? They are more in transactional services processes. So one of
Sure.
the common questions that they came up with is that, hey, how do I apply something like this on a transactional process? Be whether, I'm looking at productivity level of nurses in a hospital, perhaps, or maybe the accountants in my audit department, that I'm looking at across them. Is there a translation here that can be done, or it doesn't apply?
It does apply to situations where it's repeatable. So I've actually worked with 2 hospitals in the Seattle area using this, and especially the spaghetti diagram. So we were looking at like how meals were delivered from the kitchen to the patients, and the amount of walk steps and the handoffs and those sorts of things. As the patient was the customer, and how do you get the order to the customer as quickly as possible? And so we started looking at it that way. Is you're delivering a product and you need to get that product or service to the customer. So we started looking, same thing as how long does it take you? How far did you have to walk? And is there a way to do a handoff so that somebody else who is already headed that direction can take it for you and reduce the walk time? So, in a lot of instances, it can be used. This trick is it needs to be something that's repeatable, something that happens, every day, happens, it's a very constant thing that happens. If it's something that's just, you never know, like things like HR, it's really difficult to do that because they're not really in a pattern or a rhythm in their work.
Yeah, understood. Very much so. Now, what about the decision that to develop this tool internally, like you have, using Excel in this case, versus outsourcing or using an off-the-shelf maybe tool that can do capacity planning, that can do level loading. How do you make the decision? Why did you make the decision to develop internally?
Well, early on, there wasn't anything. We kind of looked around and we found some things that did pieces of it and some things that did another piece of it, but nothing that was one single simple piece of software that didn't require tons of licensing and usually ended up being something that you had to beg money for on a budget. So it was something that was developed about 10 years ago or more. And a few of us, a bunch of Excel nerds, as we call ourselves, kind of got together and started developing this. And then over the years, it was like little pieces got added to it and added to it. And then just recently, the capacity planning piece, because again, the company I was working for at the time didn't have it. It just was not part of their system. And so the capacity planning was being done on a whiteboard. And somebody brushed up against it one day and wiped out half of our plan. So we just said, no, we can automate this and it can be done fairly simply. So really that was the impetus of it. It was just for smaller companies, companies that this company had only been around a year. We were manufacturing ventilators in the middle of COVID. And so we were quite busy, as you can understand, and we just didn't have time to implement a new piece of software.
I'm smiling because I work with a lot of large companies that are implementing ERP systems, very sophisticated ERP systems, and they all have the promise that, we're gonna replace all these Excel spreadsheets that you're using. The promise sounds good, but when they come across deployments like yours, the reality is that you can be using SAP HANA and you're not going to substitute what you have created there because there is nothing like that on an ERP system. And it's not a real dig on anybody. It's just that it's the reality of the complexity of this. People sometimes talk about Excel systems, but there's some incredibly sophisticated, high value creation Excel systems that exist in a lot of organizations that ERP systems have a really hard time replacing.
Oh yeah. And some of the things that we've done with it now is we've made it to where Power BI can read it. and we can do some real interesting things with Power BI now.
So now you have the dashboarding capabilities as well connected to this with Power BI and analytics
Right.
as well. That's
So
fantastic.
now we can read these files across the globe at all the different locations as they start to come online with it. And we can see, you know, if somebody says, well, what's the capacity in Mexico for this product line? Is we don't have to call somebody. We can look it up on a dashboard.
Excellent. Very, very good. Listen, how do you deal with the operators not feeling like they're being micromanaged or big brother? You know, you're out there with the stopwatch clocking their time, and your standards of performance, are they fair or not? And the training, you know, that these people get. How do you deal with the human side of implementing a technology like this?
Yeah, for some stuff like that, it's I actually spend a lot of time getting to know the operators a little bit and letting them understand what it is that we're trying to do, which is make their job easier. So once they kind of understand that, I get the hovering over their shoulder with the stopwatch, because we used to have to wear a lab coat and we would keep our stopwatch in their pocket so they would never see it. And of course, nowadays we're using, you know, we use our phone to time it. But for a lot of it now, I stand there with the notepad and I have my GoPro camera recording. So I'm standing off to the side, observing. Every time they get up to walk, I make note of like, what did they walk to go get? So I always try to be like an observer in nature. You know, I don't want to scare the bird away. So I set up a camera and I quietly sit there and camouflage myself and observe, you know, reserve the wildlife in its natural environment. So I kind of treat the operators that way. But then later on, I come in and I go and I sit them down and I say, look, here's the analysis I did. Look at how many times you got up to go walk. You know, what did you go do? And they walk me through. They go, oh yeah, I have to go get parts, or I have to go get this lubricant. And so we kind of talk about what are ways to improve that. So then they become part of the solution instead of, oh, here's this person doing another time study on me. And I feel like I have to work really fast to make sure I don't get in trouble. And so it makes them part of the process. And the camera is a very unobtrusive stopwatch.
Very much so, very much so. Well, Brent, this is a terrific example, very specific application of an automation in a manufacturing setting here. Curious about what's in the horizon for you and the team? I mean, what type of things are you thinking about or pondering in terms of the next level of automation for the work that you do?
Yeah, the things that we're working on right now is because we've gone through a recent merger. ICU is actually a fairly recent purchase. They purchased the company I was working for, so I'm now an ICU employee. Our operational excellence program is everybody was doing their own thing, their own way kind of system. And so now we're sitting down and we're looking at how do we roll out worldwide one system. You know, how do we automate that? How are we going to automate everybody's KPIs into one? So that's the pieces we're working on right now is with Power BI and some of the different pieces of software that we have is working on standardizing how we measure each other and each facility and making it to where it rolls up into Power BI.
That's outstanding, Brent. Brent, thank you so much for sharing your wisdom and your expertise with our global audience today. We appreciate your time and the insights from a very real application here that's creating value. So thanks for your leadership and thanks for sharing that.
Oh, very welcome. And if any questions, feel free to hit me up on LinkedIn. I can, and of course, there's a download on the cloud for that file, fully loaded with fake information, of course. For anybody to go in there and test out.
That's fantastic. Thank you so much for that, Brent. Ladies and gentlemen, that was Brent Weichers, again, Senior Director of Continuous Improvement for North America at ICU Medical, sharing his wisdom and expertise with all of us. and we appreciate that. We are going to be taking a break now, and when we come back at the top of the hour, we're going to be shifting from medical device manufacturing to banking, and we're going to bring the topic on of self-healing automation in banking. We have Marcel Schechter with us. He's Senior Vice President and Director of Information Technology at PNC, and he is going to be discussing what self-healing automation looks like in the banking industry. So you do not want to miss that. So taking a break now, and we will wrap up the day with Marcel at the top of the hour. See you back soon.